Alright, so in this lesson we're going to look at the method of adding vectors called component addition, and in this method we use vector components to add vectors mathematically. The diagram on the left shows how this process works. If I've broken up vector f1 and f2 into x components and y components and added those two vectors up, ft is the total of the sum of those two. One thing to point out about ftx is that it's equal to f1x plus f2x. Fty is equal to f1y plus f2y. So by adding individual components, you can get the components of the sum of those vectors. This, in a lot of cases, can be easier and more useful than graphical addition methods. This is a much more robust way to add vectors. Now there's three steps to this process. The first step is to break up the vectors you wish to add into their individual components. The second step is add the components to find the components of the resultant vector, and the third step is to resolve the resultant vector. Let's look at how this works. And so you and your friends are going to go to Riverbend Nature Center to go on a hike, and you make the following movement. You do vector A 3.65 kilometers at 40 degrees north of west. You go 4.77 kilometers at 70 degrees south of west, and then you go 3.18 kilometers at 30 degrees south of east. Find the overall displacement of your group. So you're going to add A to B to C. So you could get out your graphing paper and actually graph it out and work it out that way, or we can do the component addition method. So the first step will be to find the components of these three vectors. A moves up and to the left, B moves down and to the left, and C moves down and to the right. The x component of A is going to be negative 2.65 cosine of 40 degrees. The reason why it's negative is A points to the left. Its y component 2.65 times sine of 40 degrees. It's positive because it points up. B, the x component, negative 4.77 cosine of 70 degrees. It's negative because it points to the left. And the y component is negative 4.77 sine of 70 degrees. Negative because it points down. C, the x component, 3.18 cosine of 30 degrees. And the y component, negative 3.18 sine of 30 degrees. If you calculate all these components, there's what you get for A, B, and C. You can actually check it on your own if you want. Pause the video and work through it. And if you add those up, what you get is that negative 2.03 plus negative 1.63 plus 2.75 gives you negative 0.91. And over here you get negative 4.37 is the resultant vector, the sum. What this means is that the magnitude of your total displacement from your original location, you're going to do rx squared minus or plus ry squared is r squared. You calculate r is 4.46 kilometers. And in order to calculate that angle, you'd want to do tangent of ry over rx. So 78.2 degrees. And it's south of west because you're moving down and to the left. And this angle is calculated with respect to the x-axis. You can actually work backwards and figure out and show that that is true. So your total displacement from your original location would be 4.46 kilometers at 78.2 degrees southwest. So here's a second example. Let's say a plane travels in 4 straight lines as shown above. And you have the following information about 3 of the 4 lines. A is 56 miles at 60 degrees north of west. B is 30 degrees or 32 miles at 40 degrees north of east. And D is 70 degrees at, 59 miles at 70 degrees south of west. And you want to find the magnitude and direction of Z. One thing to point out about the total displacement here, if you go A, B, C, D, you end up where you started in this diagram. If you end up where you started, the total displacement is 0. If I add A plus B plus C plus D, I should end up with 0. Now there are multiple ways to start this. That's probably the easiest way to start this. And I'm going to try to find all the components of these vectors. A, its x component is negative 56 times cosine of 60. The reason why it's cosine of 60 is that it's 60 degrees north of west. This angle here is actually the 60 degree angle. Negative because it goes to the left. Y component, 56 sine of 60. It's going to be this component. The x component of B, 32 cosine of 40. It's going to be really this angle in here or this angle in here, depending on how you want to think of it as the 40 degree angle. And D, the 70 degrees, it's really that angle in there is the 70 degree angle. So we know that we have to add these 4 things up and end up with 0. So probably an easier way to do this is to take 0 and subtract all of these to get the two components. I know that c of x has to be equal to 0. There's the components of the vectors we know. Again, you can pause and calculate to make sure that you get them the same way as well. Here we go. We got the way we can calculate c of x and c of y. If a plus b plus c plus d gives you 0, then ax plus bx plus cx plus dx also gives you 0. So 0 minus dx minus ax minus bx, or 0 minus dy minus ay minus by gives you cx and cy. If we plug those numbers in, we can calculate the x component of c and the y component of c. We can look at our diagram and see, does this make sense? A positive x component, 23.7, suggests that it moves to the right. In the diagram, it does move to the right. And negative 13.7 suggests it moves down, and it does move down. From here, I can resolve that vector, resolve the components into the vector. Use Pythagorean's theorem. It's 27.3 miles. Find the angle. We're going to find this angle in here, south of east, basically, so opposite over adjacent. We get 30 degrees, which is kind of crazy, actually. So C is 27.3 miles at 30 degrees south of east. So to kind of review the things we've talked about here, the 5 kind of main topics we've talked about over the course of the first 5 lessons. I think if you look at the first 5 lessons, one of them is this one. One of them is vectors, scalars, one right triangle trigonometry, one vector addition by graphical techniques, and the other one vector components and component addition.